Hello, math people. All right, in this quick video lesson, I'm going to go over how to solve an equation that has two steps. So first off, we've done equations so far that have all just had one step involved with them. So for example, we've looked at something like 3x equals 27. And the way that we solve all equations, the name of the game, is inverse operations. So the inverse operation for this one-step equation is the opposite of 3 times x is to divide by 3. So whatever you do to one side of an equation, you do to the other. We do inverse operations because inverse operations cancel each other out. And that isolates the variable that keeps x by itself and gives me my solution of x equals 9. Another example of a one-step equation might be 2/3. Well, let's do x plus 2/3 equals 5/7. So in this problem, to solve it, I'm going to subtract 2/3 because that's the inverse of adding 2/3. And whatever you do to one side, you do to the other. Now, this problem has a little bit extra to it because I'm subtracting fractions. So to finish this, I would have to get common denominators. I'd have to do the subtraction and get my answer. That's not what this lesson is about, so I'm not going to focus on that. But the point of this slide is to remind you of what a one-step equation is. The question becomes, what happens when you have an example like this, where there's more than one thing happening? Now it's not just something plus 7 or 4x equals 31. Now I've got multiplication occurring here, 4 times x, and I've got addition happening right here, plus 7. So if I'm going to use inverse operations to solve this equation, which is the algebraic way to do this, then what thing do I inverse first? Do I divide by 4? Do I subtract 7? Which inverse do I do? And there's an answer to that question. The correct answer is our normal way that we would approach a problem that doesn't involve a variable, just a plain old math problem. Like, let's say I had 3 plus 4 plus 5 squared in parentheses divided by 7. The way that I would know what to do first is I follow order of operations. We call it PEMDAS sometimes. But in this problem, I'm not just working out operations. I'm working backwards. I'm doing inverse operations so that I can find out what x equals. So to figure out, should I subtract 7 first? Should I divide by 4 first? You're going to go in the reverse, the inverse order of operations. If we solve equations that involve variables using inverse operations, then we're going to approach the multiple operations by going in the reverse order of operations. So what that means is the first thing you're going to look for in the problem is there any addition or subtraction? And in this problem, there is. So that's going to be the first thing that I inverse out on both sides of the equation. Plus 7 minus 7 cancels out. Whatever you do to one side, you do to the other. So that leaves me with 4x on the left side of the equal sign equals, and then 31 minus 7 is 24. All right, so I've looked for addition and subtraction, check, there's none left. So now I go to my next level. Is there any multiplication or division in this problem? Yes, there is, 4 times x. So that's the next thing that I'm going to inverse out. Divide by 4, and that leaves me with my solution of x equals 6. And that's how you solve a two-step problem. You go backwards through the normal order of operations. That's how I know what to inverse first. And always take a moment to check your answer. If we're saying x equals 6, then that means 4 times 6 plus 7 should be 31. So 4 times 6 is 24. 24 plus 7 is 31, so this answer checks out beautifully. Let's look at a couple more example problems together because seeing it once, okay, but you have to see it a few times and you have to try it a few times. So if you'd like, pause the video at any point, try one of the problems on your own, and then see if you got it. But here's our first example. 7 times m plus 8 equals 71. So to figure out what I should do first in terms of inverse operations, I like to write out my normal order of operations so I know where to start. I'm going to start at the inverse, which is addition and subtraction. So there is addition and subtraction in this problem. I'm going to subtract 8. Whatever I do to one side, I do to the other. That leaves me with 7m equals, and then when you subtract 71 minus 8, you're left with 63. And since the only operation that is left in the problem now is multiplication, 7 times m, I'm going to solve this by doing inverse, divide by 7, divide by 7. And that leaves me with the solution of m equals 9. And I know that this is right. I can check that this is right by plugging in 9 for m in the original and testing it. 9 times 7 is 63. 63 plus 8 is 71. So yes, this checks out. All right, let's look at another problem. Y divided by 7 plus 6 equals 11. Well, I've got two operations here. I've got both division and addition. So to know which one to reverse out, to inverse out first, I'm going to go backwards through order of operations, look for addition or subtraction first, which clearly there is some. So I'm going to subtract 6 as my first step. Whatever you do to one side of the equation, you do to the other side. And now I'm left with y divided by 7 equals 5. And my last inverse operation here is the inverse of divide by 7, which is multiply by 7. Inverse operations cancel out. Whatever you do to one side, do to the other, and you're left with y equals, and then 5 times 7, 35. And that is my solution, which I can check really quickly. 35 divided by 7 is 5, plus 6 is 11. So this definitely checks out and is my solution. All right, I got a couple more examples for you. Let's spice things up and let's move on to one that has fractions in it. Shouldn't be anything to get super concerned about. We're going to approach the problem the same exact way that we approached the other ones. So we're going to work backwards through our normal order of operations, meaning let's look for any addition or subtraction first and inverse that out. So minus 1/3, the inverse is to add 1/3. Those cancel out. Whatever you do to one side, do to the other. So now I'm left with x divided by 6 equals 5/3 plus 1/3 is 6/3. Now, if you get a fraction, you can leave it as a fraction and solve. In this case, though, I'm noticing that 6/3, 6/3, you could simplify that and rewrite it as a whole number. That won't always be the case, but for this example, it is. So 6/3 is the same thing as 2. 6/3 is equal to 2. So I'm just rewriting the problem with a whole number because why not? It makes it a little easier to look at. And then my last inverse operation here, x divided by 6, I'm going to multiply by 6. And whatever you do to one side, you do to the other. So I'm left with x equals 12. And I know that's right. 12 divided by 6 is 2. 2 minus 1/3, if you want to check that, will be 5/3. So there we go. Even with fractions, shouldn't be something to get scared about. We can do it. Let's do one more example. We're also going to have fractions in it. If you want, pause it, try it yourself, and then unpause and see how you did. But here's the problem. 1/4 times m plus 3/8 equals 1/2. Woo! It looks bad, but number one, you can do this. You know how to approach the problem from seeing a few other examples in here. The only thing extra is remembering how to operate when fractions are involved. That might be the one thing that hangs you up. Let's see how you do. The first thing I'm going to do is look for addition or subtraction. So I'm going to subtract 3/8 to get rid of this addition that's in the problem. And do the same thing to this side. Now when you add fractions, the one thing you have to have is common denominators. So I'm going to just rewrite this fraction problem as 1 and 4/8 plus 3/8. Now I have common denominators. 1/2 as eighths is 4/8. So now 4/8 plus 3/8, that's 7/8. So 1 and 7/8. All right, so that's the little work on the side, and I'm going to rewrite this problem as 1/4 times m equals 1 and 7/8. Now I'm thinking ahead a little bit. I'm noticing that it's 1/4 times m, which means that I'm going to have to divide by a fraction. Another thing to remember about fractions is when you multiply or divide by fractions, you can't operate when you have mixed numbers. Everything needs to be proper or improper. So I'm actually going to take this problem and rewrite it with 1 and 7/8 turning into an improper fraction, and then I'll finish off the problem. So 1/4 times m is equal to 15/8. 8 times 1 is 8 plus 7 is 15. So 1 and 7/8 is rewritten as 15/8. Okay, now to finish this problem, the inverse of 1/4 multiplied by m is to divide by 1/4. And if you know your fraction stuff, when you divide by a fraction, you don't actually divide, you multiply by the reciprocal. Some of you remember that as keep, change, flip. Keep the first fraction the same, so 15/8 stays. Change your division to multiplication, and flip the fraction, the second one, to its reciprocal. So 1/4 becomes 4/1. And then you can just multiply straight across and solve. 15 times 4 is 60 over 8 times 1 is 8. And then let's simplify that for good measure. Ooh, a lot of stuff is going into this problem, but we got it. 8 can go into 60 7 times. 8 times 7 is 56, so that means there's 4 left over. The denominator stays eighths. So 7 and 4/8, or if you want to be super simplified about it, 7 and 1/2. And that would be your final answer. M equals 7 and 1/2. Now, this problem had a lot going on because there was a lot of fractions, but this is really just the same as that first problem that we did, where we worked backwards through PEMDAS. I looked for addition or subtraction first, then I looked to multiply or divide, and then I finally get my answer. So no matter what type of problem you have, fractions, whole numbers, don't worry, you can do it. It's going to take some practice though. Watching me do it on a video is one thing. You've got to actually put pen to paper, trial and error, make some mistakes, fix those mistakes, keep on practicing. If you need this video as a tutorial though, please use it. And if you have any other questions from there, just let me know. Otherwise, happy doing math, folks.